Today we'll be discussing one of the most toughest questions that was asked in JEE Mains 2026. So let's take a look at the question. So here we are given with the function, and then we have given the we are also provided with the a1's value, and then we are asked to find an infinite sum for the same sequence, right? Now if I directly go and start to find summation n is equal to 1 till infinity a n minus 2 by n square is equal to a1 minus 2 by 1 square plus a2 minus 2 by 2 square plus a3 minus 2 by 3 square, so on so forth. It shows the unpreparedness for this particular exam, because obviously they don't want us to do in this particular method because this is highly time consuming. So we have to think out of the box for this particular problem. So what we are going to do, so let me the hint over here is, if we look at the particular function inside the summation, we are here provided with n square, and in the original sequence we are also having here n square over here. So we should somehow try to manipulate the whole problem by joining these two n square terms. So and how will I do that is, first let me write what I should find. Summation n is equal to 1 till infinity a n minus 2 by n square. Let me just substitute n is equal to 1 alone. That would be a1 minus 2 by 1 square. And now my summation runs from n equals 2 to infinity a n minus 2 by n square. So the meaning of the problem is n will be taking 2, 3, 4, 5, so on so forth for the second expression, and for this first expression I can actually find the value. a1's value is 1 minus 2 plus summation n is equal to 2 to infinity a n minus 2 by n square. So now what I am going to do is, I am going to reset the summation which is running from n is equal to 2. I am going to reset the summation's value from n equals 1. And how I am going to do that is, 1 minus 2 is negative 1 plus summation, I am going to simply write n is equal to 1 to infinity. Now you can't just simply write n is equal to 1, right? So here when n equals 2, a and b a2 and a3 a4, so on so forth. So only the values that starts from 2 is actually valid in this particular summation. But when I write n is equal to 1 and then an with it, it means a1 is also included, and we just clearly saw that a1 should not be included. The summation of the sequence starts only from a2, alright. And how will I do that? So when I write a n plus 1, when n is equal to 1, a n plus 1 would become a2, and when n is equal to 2, 2 plus 1 would become a3. So I'll be able to connect a2, a3 and then a4. So in the place of an, I can write n plus 1, and in the place of n, I can also write n plus 1 the whole square. Now when I call a n plus 1, I can also include minus 1 plus of summation n is equal to 1 to infinity I have a n plus 1 over here, alright. So let me just write it, 1 by 2 times a n plus n square minus 2n minus 1 divided by n square into n plus 1 the whole square, and I am already having 2 divided by n plus 1 the whole square, which should give me minus 1 plus summation 1 to infinity 1 by 2 times of a n plus, I can probably multiply n square in the numerator and in the denominator, and then the denominator becomes equal now, so I can simply add both the terms, n square into n plus 1 the whole square, and in the numerator I will be having n square minus 2n minus 1 minus 2n square. Now minus 1 plus summation n is equal to 1 to infinity a n by 2. When I add these two terms, I will be getting minus n square minus 2n minus 1 divided by n square into n plus 1 the whole square is equal to minus 1 plus summation n equals 1 to infinity a n by 2. I can remove the negative sign commonly out. N square minus 2n plus 1, plus 2n plus 1 n square into n plus 1 the whole square, which should give me minus 1 plus summation n equals 1 to infinity a n upon n. This would be n plus 1 the whole square if I factorize it, n square into n plus 1 the whole square. So n plus 1 the whole square and n plus 1 the whole square gets cancelled. So this would be minus 1 plus summation n equals infinity a n minus 1 by n square. Now this looks very similar, right? So just have a look at this particular expression over here and the question that we are asked to find out. We are asked to find out a n minus 2 by n square. Let me also write it over here. Summation n equals 1 to infinity a n minus 2 by n square. Okay, I've got a n by 2 over here. So this is something that I have to find, and here also we are having a n as well as a reciprocal of n square over there. Now what I can actually do is I can probably remove 1 by 2 out from the summation, which would give me 1 by 2 summation n equals 1 to infinity a n minus 2 by n square. Now if you see here, we are having the values that have. Now if you see here, in the left hand side is something that we are asked to find out, and in the right hand side we are also having the same expression. So what I can do is I can take the entire expression, or let me label the entire expression to be x. So I would be having x is equal to minus 1 plus 1 by 2 times of x, because both are identical expression. This can also be labeled as x. So if I bring 1 by 2x over here, x minus 1 by 2x would be negative 1, and if I remove x outside, 1 minus 1 by 2 is equal to minus 1. So 1 by 2 is equal to minus 1, x would be minus 2. So the answer for this expression is x is equal to minus 2.